Hello everyone, I'm Paul and today we're solving problem 2359. Find closest node to given two nodes. This one is medium and this one is all about observation, so let's start. This is a long description and maybe it's confusing also, but basically we are given a directed graph such as this one. Remember that in directed graphs, edges go in one direction only, and each node can have at most one outgoing edge. For example, this one has 0 outgoing edges, and all of these nodes have one outgoing edge each. And we're given two integers, node 1 and node 2. Let's say this is node 1 and this is node 2. And if we iterate the path from node 1, for example, we will get this. And if we iterate from node 2, we will get this path. Now first we need to find the intersecting nodes. In this case, these nodes are 2 and 3. Okay, so both paths intersect in 2 and 3. And next we need to check this part, which is basically to find the maximum distance between every source and every intersecting node. Let's see what this means. From 1 to 2 we have a distance of 1. From 0 to 2 we have a distance of 1 also. The maximum between 1 and 1 is 1. Okay, so the maximum distance for 2 is 1. Now, from 1 to 3 we have a distance of 2. From 0 to 3 we have a distance of 2. The maximum between 2 and 2 is 2. So the value for this intersecting point is 2. Next we need to find the minimum of these two values, which is 1 in this case. So the final result in this case is node 2. Okay? Once we find the minimum value, we return the corresponding node, in this case a 2. So as you can see, the problem description can be confusing, but once you get the idea, I think it's easier. Now remember, each node can have at most one outgoing edge. This means that from this source we have one possible path only, which is this one. From this source we have one possible path only. So we can use a BFS here or a DFS. For this one we will use DFS just to change because we are using a lot of BFS. Now another perhaps tricky part is that we are giving edges in the form of an array. So for example, in this case we're given 2, 2, 3 and -1. And with this we can build an adjacency list for this, and this is how we can process this array. These are the indices for each value in this array, and each index represents a node in the graph and each value represents a node also. This means that node 0 connects to node 2, so 0 connects to 2. 1 connects to 2, 1 connects to 2, okay? 2 connects to 3, and 3 has a value of -1. This means 3 doesn't connect to any node. So with this in mind, we can build our adjacency list. And this is it for the approach. With this in mind, I think you can try solve this on your own. Time and space complexity for this one will be big O of n. Now let's go with the code and hopefully you will get the idea. First, n equals length of edges. Now we are building the adjacency list. So adj equals default dictionary with a default value for every key of an empty array. So we use list here. And for I in range n, if edges at I is -1, we continue, else adjacency at I dot append edges at I. Okay, and this is a directed graph, so we end this part here. Now we can build our depth first search function. So DFS, this takes I as an argument, and here we create a stack. This is initially an array, and we will start with a tuple, which will contain the current node and an initial distance of -1. So this is node and distance, and we will create a map. We will call this distances. This is an empty map, and we will create a set. We will call this scene, and we will use this to detect cycles, okay, because we can have cycles here, and we need to add the source. So scene.add I, and next, while we have something in the stack, stack.pop, this will give us two values, node and distance, and here we can say distances at the current node equals to dist plus 1, and for every neighbor in adjacency at the current node, if not neighbor in scene, scene.add neighbor, and stack.append a new tuple with the current neighbor and dist plus 1. Okay, so we are storing the distances from the source in this map of distances. That's all we are doing here. And next we return distances. And now we can use this function to build two maps, one for every source. So map1 equals DFS with node 1, and map2 equals DFS with node 2. And result is initially infinity, so float inf selected is initially a -1, and we will return selected. Okay, this corresponds to a node, and we start with -1, because if we don't find any valid node, we return -1. And for I in range n, if I is in map 1 and I in map 2, the maximum will be max between map 1 at I and map 2 at I. Okay, so this is the maximum between the distance from source 1 to the current node and the distance from source 2 to the current node. Okay, and if this maximum is smaller than the current result, the result is now this maximum, selected is the current index. Okay, so this is it for the code. Now we'll submit this and see if it works. And this works. Remember, time and space complexity for this will be big O of n, which is efficient, and maybe you can improve LeetCode's time with some trick, but this is overall efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.